Hello guys, welcome back to another video. So in this video, we are going to be discussing about LangChain and what is LangGraph and LangSmith. So in previous video, we saw what are agents and tools and how to create with OpenAI SDK library. So in this video, we are going to be creating same tools and agent with the help of LangChain. So what is LangChain? So LangChain is a popular open source framework for building application powered by large LLMs. It helps you to connect large LLMs like ChatGPT, Grok and Gemini with tools and data. It also lets you create chains of steps like accepting prompt, generating the response with the help of model and tools, and summarize the data and output the data. So it supports persistent memory. That means you can save your previous interaction into a database like PostgreSDB or MongoDB and use those previous conversation to your new prompt. You can also build a RAG system by attaching your external knowledge database to the LangChain agent. And instead of raw text, it can also output structured JSON, which is very useful for manual scripting. Then what is LangGraph? So LangGraph is an extension of LangChain for building stateful multi-step workflow using graphs. It's very useful to building complex multi-step AI agents. It uses nodes and edges to build the workflow and it maintains state across the step. And Langsmith is a tool for debugging, testing and monitoring LLM applications. It tracks every step of your LLM pipeline. It shows input, output, errors and latency. Although it's a paid service, but you can create a free account and use it for learning purposes. So in this video, we will be focusing mainly LangChain, and for debugging and tracing, we will use Langsmith. So to create a Langsmith account, click on Try Langsmith, and in here you need to create your account and log in into it. After login, you will be redirected to this dashboard. From here, go to Settings, and in the APIs key section, you need to create your own API key. In here, you can create multiple applications, and inside this application for tracing, you need to create one project. You can create it in here or you can create it from your application also. So we will be creating in here GenAI search v2. Let's copy this and create a project. So we are using LangChain and our language is Python. So it is telling us to install LangChain and LangChain OpenAI, but we will be using Grok. LLM. So that's why we will be using LangChain-XAI. And in the .env file, we need to also set up these environment variables. Make sure Langsmith tracing is equal to true, your Langsmith endpoint, your API key, and Langsmith project. So this is our project. So for this session, we will be installing some Python libraries. So for database connection, we will be using Scikog2 binary and SQL Alchemy. So for this session, we will be using the old student DB that we used in our previous project. Then we will need pandas to render the table. Then we have .env, LangChain for our AI agent and tools, and LangChain-XAI. So this is the dependency library for Grok LLM. And we need to also install Langsmith for debugging and tracing. So after that, we need to import some libraries. So we will be importing create engine from SQL Alchemy, and we need to also import load.env, and we need to load all of our env variables. So before that, we need to go to our env and make sure you copy and paste your Langsmith credential, that is API key. Make sure tracing is equal to true, the endpoint and the project name. So we need to also create a database connection with our Postgres database. So this is our database URL, and we are using the previous student DB, GenAI DB. So next we will be configuring our Langsmith for logging and tracing. So we just need to set this environment variable into our .env file, and it will automatically activated and monitor all of your LangChain tools and agent calls. So next we will be creating agent and tools with LangChain. So first, let's start with creating a simple tool with LangChain. So with LangChain, you can create tool via two methods, that is add the tool decorator and the tool class. So first we will see the add the tool decorator. So in previous project, we create a simple tool getInfo Shubhadeep Ghodoi tool, which read a markdown template from our context folder and return the data. The template contains my information. So we will be copy this function and we'll be pasting it in here. So now to convert this function to a LangChain tool, we need to provide the tool decorator. Also, we need to import it. So previously we need to define the context of our tool. So like what is the tool name, what is the description of the tool and the parameters. But in here, when we are decorating any function with @tool decorator, the function name become tools name, the doc string become the tool description, and the function signature and type hints become the schema. We need to define our description inside our doc string inside that function. So we need to copy this description and paste it inside our doc string. So automatically at the tool decorator, we will consider this as a tool description. The function's signature and type hints. So we need to also define the types of the function output in here like this. So this become the schema. You can also define the description inside tool decorator function. So in the tool decorator function, first parameter will be your tool name, and then we can provide the description like this. So then you don't need to define the description inside this doc string. So we can just remove it. To test this function, we need to invoke this function. So we will do invoke, and inside invoke we need to pass our parameter. Because our function does not accept any parameter, we will pass empty string. So let's run it. So as you can see here, the tool call has been done, and this is our markdown template content. And let's go to Langsmith dashboard. So inside Langsmith dashboard, inside tracing, you can see this is our project name. And if you go there, there is one trace is there. So this is our tool call. So inside this tracing, you can see input. What is the input? So there is no input. This is the output, and this is the attributes. So this is the execution time. So next we'll be creating another tool, but this time we'll be using the tool class. So for this we'll be creating our second tool, query student database using prompt. So we just need to copy this and paste it in here. And inside this function we are just creating our schema, and with the help of LLM we are generating the SQL query, and with that SQL query we are fetching the data from database. But in here we were using OpenAI SDK library. We need to change it to our LangChain agent. So for this we will create our LangChain agent. So we will be importing pandas LangChain agent and LangChain XAI for our Grok LLM and Pydantic model. We will see what this Pydantic is. So first we will create our Grok LLM client. So we will be using chat XAI class, and we will need to define the model, the Grok API key, and the temperature. This is for randomness. So next we will be creating a Pydantic model to define our structure response. So we are creating a SQL query output class, and we are just extending our base model from Pydantic object. And inside this class we are just saying there the response will consider one attribute, that is query, which type will be string, and this is the description of that attribute. So field name is triple dot, that means this field is required. There is no default value, minimum length, and this is the description. So a single PostgreSQL select query. So previously OpenAI SDK library returned the JSON object as a string. That's why we need to use json.loads to convert that text to our JSON object, and then we can get the query data. But in here, because we are providing our Pydantic object, so LangChain will force LLM to generate the response with this below format. So we'll be creating our SQL query agent, and in here we need to pass our LLM. Tools will be empty array, and in here we need to provide our Pydantic object, that is response format, and this is our system prompt, that is you are a SQL expert, generate only valid Postgres select queries. So next we will be invoke this agent, and the message will be role user, and content will be our above prompt. And from this agent we will be getting our structure response, and from this response we will be accessing this query and getting the SQL query. And then in here we are just validating our SQL query, that we are allowing only select queries, and there should not be any multiple SQL query for preventing SQL ingestion. After this we will connect our database and fetch all of the result with the help of this above SQL query, and we will be creating our Panda data frame, and inside here we are just returning our used SQL query, and the panda data frame and converting this data frame to a markdown. So let's use that. Next, we will be creating our tools. So next we need to convert this function to a tool. For this we will be using tool class from Langchain core.tools, and in tools we need to define our function name, the original function and the description. So let's test this tool. So we will be invoking this tool and our query will be what is the marks of John Doe in geography. So let's check that. So this is our result. This is the SQL query and this is the result. And if you go to our dashboard and refresh it, you can also see our tool call. So inside this query student DB tool, so this is the tool and this is the input and this is the output. So inside this model we are just creating our prompt, and this model is returning the response as a JSON object with query attribute, and we are using this query to get the data from the database. So for this operation, the total number of tokens used in here, so and this is the latency 11 seconds. So next we will be creating our update student mark tool. So we will just copy the existing function. Let's copy it and paste it in here. So this is the function, converting this tool with the decorator function, and inside here we will be providing the tool name and the description. So let's copy the description from here. As you can see here, update student mark tool accept multiple parameters: first name, last name, subject and marks. So to add some description to this attribute, in previously we used this JSON context, where in the parameter we are saying this is the object, and in the properties we are saying the type and the description, and also we are providing some validation like this all fields are required to use this tool. So same thing we can do it in here via a Pydantic object. This is our update student mark input Pydantic object, and inside here we are defining our schema. So first name, last name, subject and marks, and inside here we are saying this is string and marks will be integer, and this is the description. This triple dot means this is a required parameter, and if you put some value it will consider as a default value. The advantage of using Pydantic object is built-in validation and also parsing of input data. That means it will validate all of this parameter and also automatically parse the input data via this type. So if marks is passed as a string, it will automatically convert it to the integer. And from the description, the LLM will know what this attribute means. So next we need to define this schema inside our tool decorator function. So inside here we need to add the parameter arg schema, and we need to provide our update student mark input Pydantic class. So now our tool is ready. Let's run this. And now we will be creating our main agent, and from that main agent we will be calling this tool one by one. So for this we will be defining all of our tools in this array, and we need to change this tool name. So let's change this. Okay, our tool name has been changed. Let's run this block again. Okay, then we will create our main agent. In this main agent we are providing our previous Grok LLM models. This is the tools, so we will be providing our 3 tools that we have created. Then this is the system prompt: you are a helpful assistant, use tools when needed. For DB operation, use the provided database tools, that mean these tools. Return clear final answer for the user. And we are also saying for when you are querying the database, always include the SQL query. Okay, so now we will create a function to invoke this agent. So we have created one main function, run main agent, and we are passing our user query in here, and inside here we are just invoking our main agent and passing our user query as a role user. We are just getting the message and printing it in here. So let's run this. So let's test this function. So we'll be calling this function and we are passing our query, and whatever so we will be calling this function and passing our query. So the return data will be a markdown template. So the return data will be a markdown template. So that's why we are using display and markdown to render this data inside our Jupyter Notebook console. So let's hit it. So as you can see, it's calling the query student DB tool, and this is the question. So it will automatically invoke the tool and return us the final data. So it's called the tool, return, get the data from the database, and this is our final data. So this is the SQL that has been used to get the information. John Doe score is 88 in geography class 5. So let's go to Langsmith and check the process. So inside here you can see we have one trace. So by default the trace will be named as LangGraph. We can change it later. So inside here what is doing is it calling the main model. So it's just call the model with the user query, and the model return a tool call, that is query student db tool, and this is the argument. Then the tool is invoked, and this is the input and this is the output. So in output we are just returning the SQL query and the result data. Then this state is passed again to our model to summarize the response, and this is the input. So inside input you can see all of our previous interaction. So all of our previous messages automatically passed to our next model. So this is our first message, that is user query, this is the AI tool call, and this is the AI tool response, and this is the output. So inside this output you can see this is the raw SQL, and inside here we have summarized that John Doe score is 88. So that's how you can monitor every step inside your LangChain. It automatically passes the previous messages to the next model to generate the final response, and also it calls the tool automatically with the provided arguments. So we don't need to manually call the tools and pass the messages to our next context. So if you remember, in OpenAI SDK example, we need to handle the tool call manually. So we were using a while true loop. So inside here, the client will only return the tool name and the arguments that needs to be called with the tool. Then what we are doing it here is we are checking the tool calls manually, what is the tool name, and calling the function manually, and also passing the arguments also manually. But in LangChain it is handled automatically. And also if you remember, we also need to pass the response message to our message context manually. So in here we are passing the tool call, and this is the tool response. But in LangChain it is handled automatically. So let's boilerplate code inside our LangChain. So that is one of the benefits of using a framework rather than a library. So next we will be calling our Subhadeep Ghodri tool. So what are the front-end technology stack that of Subhadeep? So let's ask this. So you can see here it calls the get info Subhadeep Ghodri tool, and from the data it's summarize the response. And if you go to LangChain and refresh it, so this is LangGraph, and it is calling the model which returning a tool call. This is the tool call. So this is the data it's quoted, the document, and with the help of this data we are summarize the data and getting the final response. In here you can see here both traces are same name, LangGraph and LangGraph. So by default is LangGraph. You can also change this label to a custom label. So for this we need to go to where we are invoking our main agent, and in here we need to pass a second parameter called config. So inside config we will be saying the run name. So run name will be main LangChain agent, and we can also define some tags like Langsmith LangChain agent, and we can also set some metadata like component will be main agent. So main agent we are invoking, and this is the user query. So let's run this and again run our tool. Okay, so let's run this tool again. So it's return the data, and let's go to Langsmith. If we refresh, now you can see there is the label has been changed to main LangChain agent. If you go there, you can see this is our agent. So this is very useful when you are using multiple agents. And in this attribute we can see so these are the tags agent, LangChain and Langsmith. And for the metadata you can see here this is the component. My component name is main agent, and this is the user query. So in this way you can also set some metadata for debugging and tracing. So next we will be calling our final tool. So for this we are just saying update John Doe's marks in geography to 90.5. So let's run it. So we can see here this is the tool call update student mark LangChain tool, and this is the parameter. So if you see here we provided 90.5, but in here we have 90, and also in the update SQL it also 90. Why? This is because of the Pydantic object. So inside our update student mark input Pydantic model, we define marks as a type of integer. That's why it automatically parse our marks data from float to integer. So that is the beauty of using a Pydantic model. So let's go and check the Langsmith dashboard. So this is our last call. It takes 8.3 seconds, and this is the API token that we are used, and this is the tags and also some metadata. So inside this workflow, we have this main agent. This is the model call. So inside this model, this is the input data and this is the output, a tool call, and this is the parameters. So in the tool call, we are calling this tool with this parameter, first name, last name, subject and marks, and this is the output. Successfully marks of John Doe of geography 5 updated to 90, and then we are passing all of these messages to our last model call to summarize the response. So in here you can see this is the summarized response, and this is the SQL query that we have used. So that's all for this video. So we see in this video how to create agents and tools with the help of LangChain, and also debug, trace and log every step of that workflow via Langsmith. So thank you for watching. If you like this video, like this, subscribe to this channel for more videos like this. In next video, we'll be exploring LangGraph, and with the help of Langsmith, we will debug, trace and log every step of our agentic workflow, which we will be building with the help of LangGraph. Thank you.